To study guide forum today, we're going to be looking at the just past the West African examination question of chemistry practical, that the volumetric analysis. Um, we're going to look at the solvings of what really came out. Now, in this question, we have said that A is 0.1 mole, the acid is 0.1 mole, and the base is 0.03 mole per dm cube of triazocarbonate. So it means that what we have here, note they said triazocarbonate, that means we don't even know the carbonate. It could be potassium, it could be sodium, it could even be any other soluble, even ammonium triazocarbonate, it could be anything. So that means they said it's what? Triazocarbonate. We know that the salt is what? Triazocarbonate. So we base, if you want to solve this equation like this, you base your calculation on solving as given to you, that is following the results, information you receive in solving the problem. Just like what they have, every other process is deleted here, the B part of it deleted here. It says that from your results and information given, not from what you already know. Say from the result and information given. So that means every information and result you receive from your titration, this is the titer value, the titration here, and then the one given to you, information given to you, is what they require that you should use to solve the problem. So in this case now, what we have here is the first thing they say you should find out is the mole ratio. Mole ratio. Oh, this is mole ratio, please. Mole ratio of acid to triazocarbonate in the reaction. That means talking about what happened in the reaction now. In the reaction, what we were given this in DMQ, this in DMQ, but what really reacted, they were the triazocarbonate is in 25 cm3, while this other one is based on what I have in my titer, average titer, the average of a which I'm going to look at after the explanation here. The second one said we're going to calculate the concentration, the concentration of anhydrous salt in gram per dm cube. So that is what we're going to find out. That means the dry salt, hydrated, the salt is dry, hydrated. So given B as this hydrated triazocarbonate. So the salt we are going to look for is the one that is dry. So the next one is a number of moles of hydrated hydrogen ion in the average titer. So we are given the molar mass of the triazocarbonate to be this. So this is what we have, and we know it's hydrated. Another thing you should know about this salt is that once you expose it to air, it tends to lose water of crystallization. So you don't just know, don't just conclude that your salt is what we know it should be. What we know it should be like this, decahydrate, because on exposure it starts decomposing, losing water of crystallization. So you cannot just conclude that this is the best based on the information given to you. That is how you're going to solve the question. So in this case now, we start by looking at the average volume of what we have here. So going by this, we have average. Now we take the one that are closer to each other, then it means 14.1 plus 14.1 all over 2. That will give us 14.1 cm cube of this. So now what we're going to do here is to calculate the mole ratio. In the mole ratio, we know that for the mole ratio of the acid to base, the mole ratio, we know that the acid has in 1000 cm cube, 1000 cm cube of the acid of the HCl, it has a 0.0 mole So then in 14.1 cm cube of the HCl will then be 0.1 over 1000 times 14.1. That will give us 0.00141 mole. That is the mole we have in this. So the next thing we're going to do is to get that of the triacyl carbonate that reacted. The triacyl carbonate that reacted. We're going to do that here now. So for the triacyl carbonate, we have a 1000 cm cube of what? The triacyl carbonate contain 0.03 moles. So now we know we use the value, the pipette we use is a 25 cm cube. That means 25 cm cube of triacyl carbonate will be 0.03 over 1000 times 25 over 1. So what we have in this case is 0.00075 moles. 0.00075 moles. That is what we have. So based on that, we will go back to. So the mole ratio will then be that of set to acid to what? Acid to what? Triacyl carbonate. Triacyl carbonate. That is to say, we have triacyl carbonate. Our triacyl carbonate, the acid is 0.004114 mole towards to that of 0.00075. So when we divide it over 0.00075, we have 1.88:1, approximately 0.2:1. That is what we have here. So the next one we're going to do here is to look at the next question that says that to calculate the mass concentration. The mass concentration. For the mass concentration, we have concentration in mole to be equal to 0.03 mole per dm cube, and then we have the molar mass. Molar mass is 0.106 gram per mole, and then the mass is what we don't know. Now, what with mass concentration, mass conc. So what you should understand here is that the concentration in mole of the anhydrous salt is equal to concentration in mole of the hydrated salt. So that means this is the same thing as the concentration in mole of the anhydrous salt. So in that case, now to get our mass concentration, what we do here, we know that mole is always mass over what? Molar mass. Molar mass. So when we cross over, we have the mass to be mass equal to 0.03 times 106. That will give us 3.18 gram per dm cube. That's what we have here. So we have 3.18 gram per dm³ for the anhydrous salt. So the next thing we are asked to find is the percentage um, percentage water of hydration. Percentage water of hydration is percentage water of crystallization. So we have our mass of hydrated salt, mass of our hydrated salt to be equal to 5 grams, mass that should be of mass of anhydrous salt is equal to 3.18 gram per dm³. This gram per dm³. So now the mass of water will be 5 minus, that will give us 1.882 gram. So now percentage water of crystallization will then be 1.82 divided by 5 times 100/1. That will give us the water of crystallization or water of crystallization or hydration to be 36.4%. Number of moles of hydrogen ions in the average titer. So what we do, we know that we have the acid hydrogen, the acid will ionize to give us, so that means 1 mole, 1 mole. In other words, but in our calculation, in our volume given to us, we say that 1000 cm³ of the acid contains 0.1. Then the average titer is 14.1 cm³. What will be contained there will be equal to 0.1 over 1000 times over 1. That will give us 0.00141 moles. Since they are in the same ratio, this is 1:1. That means it is equal to this, the number of moles that we have that reacted in the reaction. So thank you so much for being part of this revision, and I hope if you have not subscribed, make sure you subscribe, like, share, let your friend know about it, let all your friends know about it. Thank you.